Welcome everyone to our continuing video lecture series on Keep Pure Mathematics Unit 1 Paper 2. I'm not sure if it was in May or June 2019. Well, I know it was in 2019. I'm not sure if it's in May or June. But we are continuing with the questions and their solutions. So today we are at number 3. So number 3 is on trigs. We are asked to solve the equation 5 sec theta minus 2 sec squared theta is equal to tan squared theta minus 1. And we have to solve this between minus pi and pi. Well, let's get started. So we are faced with sec and tan in the same equation, tan squared. So if we are to solve this, we must eliminate one of these. So we either eliminate sec or we eliminate tan squared. And we are guided by the identity tan squared theta plus 1 sec squared. Okay, so that's the identity we are guided by. So what do? Do we swap out the sec, or do we make, or do we remain with the tan? From looking at it, it seems that I prefer to remove the tan and substitute it for the sec squared theta. Why did I decide to do that? Well, we have a sec squared theta here, but I have a sec theta here. And if I try to convert this to tan, or this left hand side with the sec to tan, that might be a little difficult because the sec theta. So I just want to try to change the tan squared into to sec theta, and let's see where we go from there. So if this is our identity, then, well, this implies that tan squared theta is obviously sec squared theta minus 1. So let's just substitute. So I will get 5 sec theta minus 2 sec squared theta is equal to, so this tan squared now comes sec squared minus 1. If you want, I could put that in brackets, and then I have minus 1. So this would be 5 sec theta minus 2 sec squared theta is equal to sec squared theta minus 2. Okay, so this is not looking too bad. Everything is in terms of sec. I didn't have any other problems, so I'm happy with the substitution I made. Now let's just carry across everything on one side. So this will, let's say 0. This 2 and this 1 will be 3. 3 sec squared theta. Then I have 5 sec, so this will be minus 5 sec theta minus 2. Great, so now you could clearly see we have a quadratic here. Sometimes I'm aware students are tempted to change the sec back into cos, or to invert it to get cosine. I would not do this at this stage. Let's remain with the question in sec, and later on we could convert it to cosine, so I wouldn't do any changeover at this time. So we will just solve this quadratic in terms of sec for an answer in sec theta. So this is 3 sec squared theta minus 5 sec theta minus 2. So I would like factors of minus 6. So you multiply these two. Factors of minus 6, that will give me minus 5. So that could be minus 6 and 1. So that will work fine. So in factorizing, so I could say 0 is equal to 3 sec squared theta minus 6 sec theta minus, plus sec theta minus 2. So 0 is equal to, let's take out 3 sec theta. So I have sec theta. This will be minus 2. And then this is plus 1. So my factors would be 3 sec theta plus 1 and sec theta minus 2. Right, so it's coming along nicely. So if this term multiplied by this term is equal to 0, then our solution would be, well, either one of them has to be 0. So we could say 3 sec theta plus 1 is equal to 0, or sec theta minus 2 is equal to 0. So this would leave me with sec theta is minus a third, or sec theta is 2. Okay. Now is the time to change over to cosine. If you recall, sec theta is 1 on cos theta. So I have 1 on cos theta is minus a third. And I also have 1 on cos theta is equal to 2. So this leaves me with cos theta is equal to minus 3, and cos theta on the side is equal to half. Well, cos theta is equal to minus 3. This is impossible. It's not a solution. The minimum value for cosine is minus 1. So this is not a solution. If you like, you could write out minimum value for cos theta is minus 1. So we will simply be using this solution where we have cos theta is equal to a half. Alright, so where if you cos inverse of a half, you get an acute angle. The acute angle, if you cos inverse this half, would be $60 degrees. That's nice. Well, you could write 60 degrees. 60 degrees is also pi on 3. So that's your acute angle. So if you recall, at the top of the question, it says that theta must lie between minus pi and pi. So they are working with pi, or your angle theta must be in terms of pi. So you can't leave it as 60 degrees. You need to change it in terms of the pi value. So if this is your acute angle, and you were to draw your quadrants A, T, and C, this all quadrant is where you would have your pi on 3. And since we're dealing with cos, this is your next pi on 3. So because we are going from minus pi to pi, the positive direction is an anti-clockwise direction like this. Okay, so this is your positive direction. So clearly one of your angles for theta, one of your answer, is pi on 3. But there's also another answer which is in this quadrant. Now because we're going from minus pi, you can't go all the way like this and say, well, you could give that angle, and that angle will be, well, 2 pi minus pi on 3. You have to give it as a negative angle. So if you are to give it as a negative angle, the angle will have to be here. And because you're going in a clockwise direction here, this is actually minus pi on 3. So we will say theta is pi on 3. And your next solution is minus pi on 3. Okay. All right, great. Let me just, all right, so the screen was a cut out a portion of the screen you were unable to see. Sorry about that. So I was saying that theta is between minus pi and 2 pi. And one of the answers, of course, would be pi on 3. And the other answer for this quadrant would be negative pi on 3, because you're not allowed to give the value for theta for a value that exceeds pi. You need to convert it between pi and minus pi, so you need to give your angle as minus pi on 3, where you go in the opposite direction, which is a clockwise direction. Okay, so let's move on to part B. So I believe part A was 7 marks, which isn't too bad. So part B, we have a function f of x, and we are asked to convert this function into the form r sine x plus alpha, where alpha is an acute angle. It would have been nice for them to say if alpha is an acute angle in radians or degrees. That was not mentioned. So naturally, I guess you guys would work in degrees because it's easier. So we'll see how it goes. Our function f of x, of course, is cos x plus 2 sine x. So we are asked to put this in the form of r sine x plus alpha. So if you were to expand r sine x plus alpha, you would get, of course, r. Put this out in a big bracket here. Sine x cos alpha, it's a plus sign, plus cos x sine alpha. Okay, so however, you remember to do it, because of course you could interchange the cos and the sine. It doesn't matter how you choose to write it. Let's write the f of x below, so hopefully we will be able to compare. Now immediately when I write it below, I see my first term is cos x, but I have a sine x here, so I would just happen to write the cos x on this side, and the 2 sine x will go in front here. Okay, so that doesn't change the question. Of course, addition is commutative. So if I were to compare, so you could see comparing coefficients. That would leave you with r cos alpha is equal to 2. And on this side, you would get r sine alpha is equal to the coefficient in front of here. The coefficient in front of here would be 1. Okay. So now we just have to find r and alpha. So let's start off with r. So what you do is that if you square this expression and you plus it to this, you're going to get r squared cos squared alpha plus r squared sine squared alpha is equal to 2 to be squared plus 1 to be squared, which is 4 plus 1, 5. So r squared cos squared alpha plus r squared sine squared alpha is 5. So if you want, we could factorize out r squared, and you're going to get cos squared alpha plus sine squared alpha. This is an alpha. I don't know why I wrote x is equal to 5. And of course, you know that cos squared alpha plus sine squared alpha, well, that is equal to 1 from the identity. Cos squared plus sine squared is equal to 1. So this is going to leave you with r squared by 1 is 5. Therefore, r is equal to the square root of 5. Now, if you have to take the square root in this scenario, of course, you would normally put plus or minus here. But we accept only the positive value in this case. So we accept positive value for r. Alright, so that's what we normally do. We leave out the negative value that you might get when you have minus, plus or minus. So we have r. So next we have to find the value for alpha, which is simple as well. So if we say r sine alpha divided by r cos alpha, well, the sine alpha is 1 and the cos alpha is 2. So therefore the r's will cancel each other out. And then sine alpha, you're going to be left with sine alpha over cos alpha is equal to a half. Next way of saying that is tan alpha is equal to a half. Therefore, alpha is tan inverse of a half. And the value that I have for that is 26.57 degrees as alpha. So therefore 2 sine x, again, sorry, I need to pull up my screen. 2 sine x plus cos x is equal to root 5 sine x plus 26.57 degrees. Okay, so that's the form that you asked to give the expression in. Okay, now my only concern is that did we have to work in degrees or did we have to work in radians? Would this come back to haunt us? Let's see. Let's continue. So that was part B, part 1. So part 2 says, hence or otherwise find the general solution for cos x plus 2 sine x. Hence or otherwise. Okay, I think this part is only worth, well, I shouldn't say only, but it's worth 3 marks. So they say hence or otherwise. So you could obviously use the otherwise and form probably tan x on this side and try to solve it like that. But let's utilize the hence part of it and use this format here to solve for the expression cos x plus 2 sin x is equal to 0. So we know that cos x plus 2 sin x can be written as 5 sin x plus 26.57, and in this case we have to make that equal to 0. So therefore, if you have this equal to 0, well, you could get rid of the root 5. It's just this expression here is what they want to be equal to 0. So sin x plus 26.57 is equal to 0. So in the question, they use this expression, general solution. So what do they mean by general solution? General solution would mean that whatever solution you give, it must satisfy whatever unique answer you may derive from this expression. What do I mean by that? Remember, sine and cosine are cyclic functions or periodic functions. They occur for different periods. For most of the time, when you solve these expressions, you normally solve it between 0 and 360. 0 and 360 is the same as minus pi to pi. But these expressions would have solutions beyond 0 to 360. So if you continue on with extending the period to 720, etc., you will get other solutions. So general solutions the form of a general solution must take into consideration all these different cycles or different periods. So in this case, we are saying sin x plus 26.57 is equal to 0. So x plus 26.57 could be equal to, when you sign inverse 0, well, 0 is one answer. Another answer would be 180. 360's answer as well. 540's answer. How did I get 540? Well, if you add 180 to 360, you would get 540. Yeah, and then it goes on. So we want this general solution that will satisfy all the scenarios where we have sign of this expression is 0. So this goes on because it's periodic, it's cyclic. So if I rewrite this as 26.57, so this is 0. This is 180. The second answer, 360, well, that's 2 by 180. And 540, well, that's 3 by 180. So you could immediately see a pattern here. So I could say x plus 26.57 is equal to n by 180. Oh, sorry, I probably should write it as 180n. And I will say where n is 0, 1, 2 and continues. Now it would have been nicer to write n pi, but the reason I'm not writing n pi is because, well, I kind of worked out his answer in degrees. I wasn't asked any question to work it out in terms of radians, so if I want to write n pi, I need to go and convert this back to radians. So in this case, I would remain with my answer in degrees because I worked it in degrees. So continuing on, so I would say x is equal to 180n minus 26.57, where n goes from 0 to 1 to 2, and it continues. So this is your general solution, because you are able to find this x value for different periods or different cycles of n. N is not confined between 0 and 360 or minus pi and pi. You're allowed to move on. So this, I would say, is the general solution. Okay, so let's continue. So the question goes on to say, determine the minimum value of 2 over 2 minus f. Now you might be tempted with when you see the word minimum to think that, you know, you might have to differentiate in this situation, but that is actually not the case. So the expression 2 minus 2 over f, so let's rewrite this. So we are asked, so let's change to blue. That is 2 over 2 minus, let's write it in the form we were asked, the r sine theta form we were asked to put it in. Sine theta plus 26.57. Alright, this divide sign goes all across. Looks ugly. I just wanted to make that clear. So we are asked to find the minimum value of this expression. So you could see that sine theta plus 26.57 has a minimum value of -1 and a maximum value of 1. So we just make that statement because this is the scenario for sine. Of course, it's the same for cosine as well, that you have a minimum value of -1 and you have a maximum value of 1. But we would like the minimum of this function. Alright, so we want the minimum of this function. So if I want the minimum of this function, that means that I want my denominator to be the largest it could be, or I want my denominator to be a large number in order to get the minimum. So 2 minus root 5 sine of this expression, we would like it to be the largest value it could be. So it will be the largest value this denominator could accept. What happens when sine has the maximum value of 1? Not the minimum value of -1. We want this denominator to be the maximum value, so the overall expression will be the minimum because you have to divide by a larger number. So you could say 2 minus 5 sine theta plus 26.57 is a maximum when sine of theta plus 26.57 is equal to 1. So therefore the minimum of 2 over 2 minus f is equal to 2 over 2 minus root 5, and you're going to have to multiply by 1 because we just said that this expression here is 1. So you can't leave your answer like this. This is a third, it's in the denominator, we need to fix this up. So in order to do that, so let me just write you can multiply the top and bottom by 2 plus root 5 to change this denominator from a third to a number. So you could have 2 minus root 5, 2 plus root 5 over 2 plus root 5. Right? So I multiplied top and bottom by 2 plus root 5. Of course, that's just like multiplying by 1. And I did this to get rid of the minus 5, or to get rid of this third as my denominator. So I'll be left with 2 into 2 plus root 5 all over, this would be 4 minus 5. So you're going to actually get a negative number of minus 2. 2 plus root 5. And I would be happy to leave my answer in this form. Some of you might convert your answer to decimal, although that is not ideal. I'm not sure if CXC would have given you the same mark for using a decimal as it is for converting this to this form, but just for your knowledge, the decimal value is minus 5 for 0.882. But this is the exact form, and this is the form I would prefer. Okay, so that's the minimum of this function. So let's move along. Okay, so this is the last part in number 3, and it's an identity, and I'm glad it's last in the question because normally you spend a lot of time trying to prove an identity. Students as well, or candidates, do get some problems when proving identities. So it's probably good it's last in the question. So I'm asked to prove this identity involving a double angle for tan, or multiple angle, and then a multiple angle for cosine. Now the question that you always ask yourself first when doing an identity is, where do I start? Do I start on this side, or do I start on this side? I would say that I would like to start on this side. I would like to start on the left hand side because I believe I have a little more wiggle room than this expression on the right, meaning that I have the capability of simplifying this expression into sine and cosine, and it may be more difficult to move from cosine and sine to tan than it is to move from tan to sine and cosine. So I would prefer to start on this side. So before I start on this side, let me just remind myself of the identity tan a plus b and what that actually is. So tan of a plus b is equal to, of course, sine a plus b over cos of a plus b. You could also write out the expression tan a plus tan b all over 1 minus tan a tan b. Right, so let us you see, you immediately would want to jump and use this expression to break up tan a plus b into something similar, simpler. But you must always look over on what you have to prove on your right hand side. On my right hand side, I see I have a cos a plus b. Okay, so I have this cos a plus b, and when I write tan a plus b into this expression, I have that cos a plus b remaining here. So let me first change tan a plus b into this expression before I have to go to this expression. If I have to use it at all, I'll just keep this. So I'm going to write this left hand side expression, and then I'm going to convert sin a plus b into tan a plus b, into sin a plus b over cos a plus b, and see if I could simplify it and get this expression, because I happen to see a cos a plus b here. So that's why I'm doing that. So tan a plus b minus tan a is the same as, I say, sin a plus b all over cos a plus b minus, let's change this tan a to sin a over cos a, because that's what the right hand side has. It doesn't have any expression with sine, so I'll just say minus sin a over cosine a. Sorry, so accustomed writing theta. That's an e. Okay. Now I notice that my denominator, if I have to simplify this expression, my denominator would be cos a plus b multiplied by cos a. And I'm glad, because I see that's the denominator I have over here, cos of a and cos of a plus b. That's my same denominator here. If I try to simplify and I get my common denominator. So that's probably means I'm on the right track. So let's do that. So my denominator will be cos a plus b by cos a. So if I take this expression and multiply it by sine of a plus b over cos of a plus b, that would leave me with sine a plus b. You multiply this expression cos a plus b by cos a, you get minus sine a cos a plus b. Okay, so where do we go from here? Sorry, I left out a cos a over here. I will re-explain. So I left out a cos a when I multiplied. So this here would be a cos a. So the denominator is cos a plus b by cos a. So when I take this denominator and I multiply it by this expression, the cos a plus b cancels. So I have cos a sine a plus b. Take this denominator, multiply by this expression, I have sine a by cos a plus b. Okay, so I have the denominator over here, it's the same as this denominator, but somehow the top will simplify or collapse into sine of b. Now how does it do that? Now you may be tempted to expand sine a plus b, and then you expand cos a plus b, and then you simplify the numerator and you'll get your answer. Yes, that will work. It's a lot more work, but yes, it will work. But I want you to spot that cos a, sine a plus b minus sine a, cos a plus b is of this form. It's, if you have to write sine of a plus b, or let me not use a plus b, because that's there. Remember this formula. Sine of alpha plus beta is equal to sine, well, it's a negative because we require a negative sign, right? So sine of alpha minus beta, because of this negative sign here, is sine alpha cos beta minus cos alpha sine beta. That is the form that this numerator currently is in. So you have the cos of a, and then you have the cos of a plus b. Then you have the sine of a plus b, and then you have the sine of a. So this top numerator could be simply written as sine of a plus b minus e, and then we have the denominator, sorry, which is cos a plus b cos a. Because when you substitute alpha for a plus b, if a plus b is alpha, then this is alpha here, and a will be beta, and this is beta. So you have sine of alpha, we have that here, cos of beta, minus, then you have sine of beta, all right, we have that here, cos of alpha, cos of alpha. So this expression, when you substitute alpha to be a plus b and beta to be a, you are able to write that numerator as sine alpha minus beta. So now I could simplify this expression to be, well, you have sine a plus b minus a, so the a's will cancel, so you simply have sine b over cos a plus b cos a. Okay, so that ends your proof, and that ends number 3 for 2019 paper 2. Look forward for question number 4 very soon. Thank you for listening.